Hello everyone, this video is about genetic mapping. By definition, that is a schematic representation of various genetic markers in the specific order in which they are located on a chromosome along with the distances between them. By visual, it looks like something like this. Here we have a diploid animal, my very favorite Labrador Retriever dog, with 3 linked loci, each with 2 alleles for color, tail, and demeanor. All letters on top represent dominant traits. The ones on the bottom are recessive. Now let's assume that our distances between these loci, B and S, is 12 centimorgan. Between S and F is 8 centimorgans. A centimorgan is a portion of the chromosome of such length that on average one crossover will occur in it out of every 100 gametes formed, or equal to the percentage of recombination between the loci. That means that this is actually 12% of time, or 0.12, 8% of time, or 0.08. We'll get back to this in a little bit. Did I mention crossover? That is the physical exchange of ordinarily strictly homologous segments between homologous chromosomes. Let's breed our pure dominant female with a pure recessive male. Now, all of the recombinants occur from different events, from single crossovers and double crossovers. Single crossovers has region 1 and region 2. The double crossovers are nothing but swapping in between the middle. Each event produces 2 new gametes, plus the 2 original gametes from the parents. Now we have the total of 8. Let's see that on the table. Here we have all of our genotypes, the events that they occur from, and all of their phenotypes. Now, once we have predicted the probability of all 8 gamete types that would be created by the heterozygous individual, we can now calculate the probability of each event occurring and the probability of specific gamete resulting from this event. How do we do that? Of course, by formula. Now, do you remember our first page? Let's go back to it. In order to calculate these frequencies, we need, of course, our centimorgans. But we also need a very important coefficient, and that is the coefficient of coincidence. Possible to calculate, but let's assume it's 0.5. To calculate the double crossovers, we need region 1, which is 0.12, times region 2, 0.08, times our coefficient, the 0.5. That gives us the number 0.0048. To calculate the single crossover in region 1 only, it's region 1, 0.12, minus the double crossover event that we calculated this number, gives us this number, and so on. Now, to calculate the probability of a specific gamete, that's nothing but dividing all these numbers by 2, simply because each event produces 2 gametes each. Thank you.